Hello, my lovely viewers. Let's take a cool look at this question. This question we are asked in the reaction above. Look at the reaction here. We are now given that this reaction represents what? We have different options here. Now, of course you can see that when anytime you see a reaction like this equation is what? A nuclear reaction. All right, a nuclear reaction. And now, what do you understand by nuclear reaction? Nuclear reaction. A nuclear reaction, there are processes that occur changes in the nucleus of an atom are what we call nuclear reaction, and there are 6 major types of nuclear reaction. I'm going to group them into 2. We have natural nuclear reaction and we have artificial nuclear reaction. I'm going to list them out, then explain all their processes. A complete video of it will be on my YouTube channel. All right, just go there, look at Ojemai TV, go there and subscribe and watch the complete video on nuclear reaction. Now, these are the 6 major nuclear reactions. We have 1. We have what we call alpha. We have what we call alpha. We have alpha decay. Number 2, we have beta decay. Number 3, we have a positron. Now, these 3 are what we call natural nuclear reaction. They are occur naturally. We have 4. We have artificial. Artificial we have artificial transmutation. We have 5. We have 5 as what? Nuclear fission. Various nuclear reaction: alpha decay, beta decay, positron, artificial transmutation, nuclear fission, and nuclear fusion. So I'm going to explain all of them, including their reaction like this one, so that you can be able to identify this reaction is for what. Alpha decay, it is when an unstable nuclei emit an alpha particle, like say helium particle. Do you get that? When unstable nuclei emit helium particle is what we call what? Alpha decay. Example, we have uranium. Uranium has atomic number what? 92. Mass number what? Mass number of 238. Will what? Emit what? An alpha particle, which is what? Helium, to give you what? To give you thorium. Thorium with what? With atomic number what? Atomic number 90. Mass number what? 234. Plus what? Plus helium particle. Are you following? So there is what? A decrease of what? Of mass number by what? Decrease of what? Mass number of 4 and atomic number of what? 2. So anytime you see equation like this, it is what? It is alpha decay. Alpha decay. Among the options here, this equation is not so it's not an alpha decay. Anyway, alpha is not in our options. Now let's go to beta decay. A beta decay is when the neutron in the nucleus is converted or changes to what? To proton emitting electron. Are you following? When neutron in the nucleus changes to what? To a proton, is being converted into a proton emitting electron, is what we call what? A beta decay. And look at the equation. We have carbon. Carbon has atomic number 6, mass number of 14. That is an isotope of 8. We undergo a reaction to give you what? Nitrogen 14, atomic number 7, plus what? Plus electron minus 1, 0. So anytime you see equation like this, it will signify what? It signifies beta decay. Are you following? Beta decay. So look at this one has transferred. Now you can see that there is increase in what? Atomic number. But here there is what? Decrease in what? Atomic number. Are you following? This one is helium particle, but this one is what? Minus what? Minus 1 electron as what? Atomic number. Are you following? Now, what do you understand by a positron? A positron, this one involves a neutron changing into what? A proton emitting what? Electron. A positron, a proton will change to what? To a neutron, emitting a positive electron. Proton change into what? Neutron, emitting what? You have carbon here. Example, we have carbon 6, atomic number 11 is one of the isotope. Will give you what? A positron, which is what? A boron 5, 11 plus what? Plus 0 plus 1. You can see this one is what? Positive. This one is what? Negative. So anytime you see equation like this, it is what? It is a positron. All right. So with that, look at now. We have the same thing here. So the answer is what? A positron, which is what? Option D. A positron will always emit what? A positive electron. Is that understood? Now let's go to artificial transmutation. Now artificial transmutation has to do with when unstable nuclei is being bombarded with a particle, which could be a helium particle, that is an alpha particle, and also a neutron. Let's look at the example. Example, we have what we call we have nitrogen. Nitrogen has a mass number 14, atomic number 7, plus what? Plus a helium particle. Remember, you bombard it with either a helium particle or what? Or a neutron, plus what? Helium particle 4, 2 will give you what? Will give you oxygen, atomic number 8, with what? Mass number what? 17, plus hydrogen. If you see any type of equation like this one, artificial transmutation, it is either is bombarded with a helium particle or a neutron. Neutron is like this, N10. Anytime you see mass number of 1, atomic number of 0 in a reaction like this, it is what? It is artificial transmutation. Do you understand? Now let's go to nuclear fission. A nuclear fission is when a heavy nucleus is being split into two smaller nuclei when hit by a neutron. Do you understand? When you carry a neutron and hit that heavy nuclei, now when we look at nuclear fission, a nuclear fission is formed when a heavy nucleus is being split into two smaller nuclei when it is being hit by what? By a neutron. When you use when this heavy nucleus absorb a neutron and is being split into two smaller nuclei, is what we call what? Nuclear fission. We have something like uranium. Uranium will have atomic number 92, mass number of 235, plus what? Plus a neutron 10. I told you that it will absorb a neutron. When it absorb a neutron, will now be changed to what? To barium. All right. We have product like barium. Barium has atomic number 56, mass number of what? 141, plus what? Plus krypton. Krypton are released 3 neutrons. 3 neutrons are what? Released. There is what? A release of what? 3 neutrons. So anytime you see equation like this, what? A nuclear fission. All right. A nuclear fission, one heavy nucleus, when absorb a neutron, it will now split into what? Into smaller one with 3 neutrons being released. And of course, all of this one will always release what? Release energy. Now let's proceed to nuclear fission. When we looked at nuclear fission, when two smaller nuclei, light nuclei, combine to form a heavier nucleus with a great release of energy, is what we call what? Nuclear fusion. Small nuclei combine together. For example, we have hydrogen. We have isotope of hydrogen. This is deuterium combined with tritium. This is deuterium combined with what? Tritium, to give you what? Of course, helium 42 plus what? Plus neutron. Are you following? So if you see any kind of equation like this, it is. Now for more of this video, do well to like, importantly share this video, share and comment on it. Thank you for supporting. God bless you.